Hi everyone, Tony here. Welcome to class number 2, C4D 218, Procedural Layer Shader Techniques in Cinema 4D. The entire class this week is going to be spent inside the material editor in C4D, where we're going to compare the differences between R15's material editor versus the powerful new R16 reflectance channel and see what else has changed in there, and maybe even tap into a hidden setting somewhere you've always ignored because you didn't know what it did. And the good news is not a lot else has changed in the material editor from R15, so if you're already familiar with what the other channels do, you're pretty much set. But if you're like me, you probably hover over a setting and you think to yourself, I'll get around to learning more about that later when I'm not under a deadline. And then I never get around to that later. Again, this isn't a beginner course in Cinema 4D, so I don't want to bog us all down explaining every little whistle and bell and settings in here, but I want to go over the highlights and the basics of this at a decent pace. But before we jump into that, most of us are self-taught, and we gain an interest in a piece of software and we start messing around, and then we get hooked and we try to learn as much as we can on our own. But sometimes this means we don't always understand why something works, we just know that it works. Well, I feel the more knowledge I have about something, that just makes me more valuable as a candidate in the marketplace. And having a better understanding of the tools I use to make a living takes away the mystery and the stress of flying by the seat of my pants, and it makes me more confident that I can get the job done. And with that, we're going to go over a brief history lesson in computer science, because this is school after all. All of those strange names for settings in 3D programs. What do they mean? Who came up with them? And you probably guessed it correctly, they're named after the people who developed them. Phong shading was developed in the 70s by Butong Phong at University of Utah, and it's been a standard model of reflectance and shading for decades, and it was considered an improvement from Henri Gouraud's technique because it produces better, smoother renders than Gouraud's shading, and that explains why the Phong tag in Cinema 4D gives the appearance of smoother surfaces on geometry instead of faceted flat surfaces. Jim Blinn from JPL and also University of Utah modified the Phong model and developed the Blinn-Phong modification. Blinn-Phong is the default shading model used today in OpenGL, and it interprets the values between vertices using the Gouraud shading method. And Cinema 4D uses Blinn-Phong in the editor preview window because it's fast and it requires a lot less processing power than Phong. And that explains why renders take longer and why the editor previews look so cruddy. Now, in R16, Lambertian takes the place of the Phong and the Blinn shading models. It's based on Lambert's law, which describes a surface that exhibits the same radiance when it's viewed from any angle, named after Johann Heinrich Lambert from the late 1700s. This basically defines a surface that appears to have the same brightness and value all over, like smooth diffusion. That's why this is the base of a color channel that lives under reflection and specular. It's dull and flat and diffused, kind of like clay. Then we add the shiny wow factor stuff on top in the reflection and specular channels to give that ping and make it look really juicy. Oren Nayar reflectance model was developed in the 90s by Michael Oren and Sri Nayar from Columbia University. And this accurately recreates how light reacts to rougher surfaces like sand and stone and concrete. And I'll show that example as we start poking around through the material editor. But first, let's talk about document preferences, because this could really mess up your project's workflow down the line if you aren't careful. Here we are in R16, and the setting I want to show you is also available in R15 and R14, and I believe it's also available in R13. I'm not quite sure when they introduced this. It's in your project settings down here. Linear workflow and input color profile, and I can't specify how important this is to decide what color space you're going to work in and stick with it. You cannot change your workspace mid-flow because everything will change. I'll show you some examples in a second. But linear workflow is basically here. If you look under your render settings and you go to multipass, when we just do a regular output, we get the RGBA image. So we just get a flattened composite, but Cinema actually calculates every one of these layers when it renders. It does a separate layer for specular and shadow and reflection, and it has blending modes like Photoshop to combine them all together. So specular is a screen layer, shadow is a multiply layer, ambient occlusion is a multiply layer, and so on. And then these all get stacked in order with proper blending modes. But it's very crucial that If you work in a linear workflow in Cinema and export a layered multipass file, you need to composite these in your compositing software in a linear workspace as well, or they're not going to match the merged beauty pass, this RGBA images of beauty pass. So if you bring everything into After Effects or Photoshop or Nuke, and you start blending your screens and your multiplies and everything, and they all total up to look nothing like this master image. So if you ever do multipass outputs, I also suggest you do an RGBA image, or you just, in the save dialog, you save a regular image as well as your multipass layers here. So you have something to compare. What is my render supposed to look like? And then here are all my stacked layers when I put them all together in After Effects or Nuke. Hopefully they look the same as the flattened version that I'd done. Now it's crucial here. I have a default texture, an 18% gray. I'll explain this more when we start building materials in another class. But for now, let's take a look. Slide this over for a moment. If I go back to Command D to get to my project settings, we're in a linear workflow in sRGB space. Now I can change sRGB. I could just disable the color profile and look what happens. It shifts. Actually, I want to move this window out of the way so you can see my other materials that I have in my default library here. By default, sRGB is on, and you can see how in a linear space, how important it is to have a color profile to show you how your colors are being interpreted. Now, sRGB is a very common ICC profile. All consumer digital cameras shoot default with sRGB. Images you look at on the web, on your smartphone, everything. It's just a global standard of color, trying to stay on top of color management. So if you're rendering a file here in Cinema in sRGB and you open it in Photoshop, make sure you're respecting the sRGB color space, and that way you'll see that your image that you render in here should match when you open it up in Photoshop. Now you can see again, if I disable it, this is how Cinema is rendering a linear workflow with no color management enabled. I can also switch to the linear color profile in linear space, and it seems to be behaving the same way as no enabled color profile, and that's because linear space cannot embed profiles. So it's strictly handled by the color management of the software that you're using. But if we are in linear profile and turn off the workflow, now you can see it's pretty dark. Linear, and again, we go back to sRGB and turn on linear. So you can see a combination of everything is going to give you the right mix of what you want to do. So you need to know what you're working in. And now by default, Cinema's just said, okay, everybody's probably using sRGB and you're probably going to be compositing in linear workflow. So I highly recommend, if you've messed with those settings, put them back, just because it'll make your life easier if you start working with effects houses and they're looking for a linear workflow, and they're probably going to be tagging things with the sRGB color tag. So the reason I said this is important, though, is look at my little thumbnails down here and the values that they're being displayed in a linear project in sRGB. And when I uncheck the button over here, you can see all the icons redraw, and now they're a lot darker and duller. Like watch the black point here in this sphere, and look at the other spheres here. I'm going to turn that back on, linear. And now you're going to see how the colors blend better together. So if I start designing a specific texture and a look and a value of it in one workflow, like a linear workflow, and then in the middle of my project, I turn off linear workflow, it's going to change the way all of my layer shaders interact with each other, and all of the textures are going to look different. So again, pick it at the beginning and don't change it, and you'll be fine. You can see I have a custom layout here, so you can set your own by just right-clicking out in the open and do customize palettes, and then you can build your own palettes. That's, there's a million tutorials teaching you to do that, but that's where all your settings are. This is why I have my layout the way I do. I'm going to keep it this way throughout the class. But so down here, I just put a quick link to preferences. So my preference window opens, and down here under view, you also have the display color profile. And again, by default, Cinema has that set to the sRGB color profile. So that means if you bring in any texture maps that are most likely embedded with sRGB, Cinema will display those images with the right color profile. And you have the option to load your own monitor profiles in here. But again, I suggest you leave things default. The reason I'm bringing this up, and color management is just a wormhole of information. I just bring it up because we are specifically talking about building layer textures that are heavily dependent on blend modes. And I just want to make sure that you know that the way everything goes together is dependent on this workflow and how they blend in color spaces. So that was that bit of information. Now let's start comparing the new material editor to the old one. Okay, so we have R16 here on the left side of the screen, R15 on the right side of the screen. Everybody's lined up so we can compare the channels across the board. And we'll start off here in the color channel. And you can see the top of the screen, the settings are still identical up to this section here we'll get to in a second. Your color picker, you have the option to change the settings, the sliders, color table, and you can add quick storage and mixing panels in here. And as well as you have the option to change these settings out here as well. You can change this to the color table out here. I like to keep it nice and clean and condensed, and that's why I've got everything kind of neat and tidy here. But you can also change the values of these sliders from percentages to numerical values. And then each channel slot has a brightness slider, and that basically controls the opacity of that channel and how it blends with the other channels in the stack. So by default, each channel has the brightness slider at 100, but then you have the ability to lower the strength of a channel in combination. So what's this model shader over here? In earlier versions, in R15 and before, it was hidden away here in the illumination channel down at the bottom. Now this is confusing because the shader models are diffusion, not illumination. And not to be confused with diffusion in the material editor, which is a multiplier channel, but it's how the light diffuses onto a surface of something. So it receives illumination, so I can understand why they had it in here, but it doesn't generate illumination. So it was really confusing in here, and I'm glad they moved it into the color channel where it's supposed to be, because it's diffused color. So in R16, if you look at the illumination tab, you'll see you have the generate, global illumination, receive GI, and caustics, the same settings here and all the value sliders. So briefly, what this means is when you're using global illumination, every object in a scene has a reflectance value to it. So light bounces off of an object onto another object. And by default, all the material strengths are set to bounce at a standard value of 100% of the bounce. And then you can control if there's too much light bouncing off of something, you can dial it below 100% here. But if you want an object to give off more reflective light, you change the generate GI value and you bump that setting up. Now that doesn't make the object itself brighter. It just means the light bouncing off of that object will be brighter. And that's handled here properly where it belongs in the illumination channel. So the diffused color model goes up here where it belongs, and now people are going to be more aware of it, and it's not going to be tucked away and hidden here, because there's some interesting settings that most people probably just glance over because they didn't know they could change them. So if we look at material here in R15, we're going to hide R16 in the back for a moment. If you look here in the model, you have three render types. You've got Phong, Blinn, and Oren Nayar. And a default material in Cinema 4D consists of a color channel with an RGB value of 204 and a soft specular. So if I turn the specular on and off, you'll see this dull diffused highlight in the center here, turn on and off. So in the illumination channel under the shading model, the default is set to blend, which is ideal for smooth surfaces. You also have Phong, and if I change Phong, watch that specular here. It becomes kind of a shinier, harder specular, and it's a little more apparent here in the tiny view. And blend is more diffuse. So this gives you a nice soft base material to start with. But interesting here, if I turn off specular, and I look at the blend model, and I change to Phong, there's no change at all. So the difference between Phong and blend is happening in the reflection or in the specular. It's not happening in the base diffusion. Okay? So again, turn specular off, and we change the model from Phong to blend, and they look identical. Now another setting here is the Oren Nayar, and as explained, it simulates rougher surfaces like concrete or plaster. And you'll notice when I activated it, there are two settings that are grayed out before that now become active. There's a diffuse level, which determines how much light is diffused onto that surface, and you can go above and below 100 on those. And then the roughness value, and you can increase this roughness, and I think it maxes out at 200, so it kind of dulls the surface even more, so this, it starts looking like clay even more. You can also bring this all the way down to 0. Now also interesting, if I take the Oren Nayar shader, the roughness down to 0, and then I compare this to blend, there's no change at all. That's because the Oren Nayar was developed to emulate more rough surfaces, so if there's no roughness, it's not emulating anything differently. So let's just bring that value back up. And now you can see we have a rougher surface. So compare this shading model over here in R16 now. Now we're in the color channel, and Phong and blend have been replaced with Limbertian. Again, the same settings here. You have the diffuse fall off, and as you change this, it affects how the light falls on this object. And if you really crank this up, it starts to take on kind of a sketch and tune feel to it. And then the other model is the Oren Nayar. And again, it does the same thing. If I bring the roughness all the way down, it looks just like the Limbertian model. Okay. So they're in two different spots, but as you can see, they have the same effect. So what happened to Phong and blend that's over here? Phong and blend have been replaced by Limbertian in the diffuse shader, but blend has been combined with specular, and specular has been combined with reflectance, and those are now in the reflectance channel in R16. So you'll notice there's no more specular channel down here. And if you come into reflectance, by default, any new material you create gets a default specular channel. So this is basically the same channel as this specular over here, and it just looks slightly different. You get a preview of it now, but you'll see that this little hump here looks like this hump here. And then the color slider and brightness and texture, that's all down here at the bottom now. Your width, height, fall off, and inner width. You have width, fall off, inner width, but then height now becomes specular strength. And then you'll notice here under the type is the legacy shader, which means previous to R16, and the specular is using the blend model. And you also have the Phong model. So look at your little preview here. If I change from specular Phong to specular blend, we get the same specular fall off on there. So blend and Phong from the shading model, legacy shading models, have been moved into the specular channel, which has been moved into the reflectance channel. And then Limbertian takes the place of the diffusion parts of those channels, which you remember in here, if we turned off the specular and we compared Phong and blend, they have the same diffusion. So that becomes Lambertian. And then Phong and blend, which is the specular hits on these things, the difference between blend and Phong specular, now happens over here in the reflectance, in the legacy, blend and Phong. Make sense? So what is this telling us? This is telling us that anything we could create over here in R15, we're going to be able to create over here in R16, even though things have moved around a little bit. But all the legacy settings are still available to us. Just know blend and Phong are now used to affect the default specular, and their diffusion properties are now being called Lambertian in this model here. I hope that makes some sense and clears up a little bit of confusion. Diffusion in R16 is identical to diffusion in R15. There is no upgrade or change. But let's take a look at what diffusion does. Diffusion is a multiplier layer. So think of that like the multiply blend mode in Photoshop, where pure white doesn't affect the channel at all, and anything less than white will have an effect. And we could demonstrate this by throwing a noise shader in the texture slot here. Now you can see the black and white noise is multiplied on top of the diffused color in the color slot here. So if I change our color of our ball to red and turn diffusion on, this gets blended in a multiply mode. So the white is being multiplied out and only the black is showing through. So you'll notice this is set to normal mode. So if I change the brightness of this value of this channel, nothing's happening here because this slot is overriding the brightness completely. But if I bring the mix strength down to 0, essentially turning that off, now you can see the brightness slider has an effect on the channel here. Then you can bring that mix strength back and say, mix this noise with this brightness at this opacity here. Again, if I bring the value of this down, and this is at 100%, it's completely overriding this setting here. But then I can change this from normal mode to multiply. So now I have a multiply within a multiply, because now it's multiplying out the white and telling this, whatever texture is in this slot, and in our case it's a noise channel, zero out the white, make the white transparent, and only show the grayscale values or black. Now mix that with this value. So now these two are combined together. And again, I can change the strength of that as well. And those two then get blended together in combination. So again, if I change this to normal, then it ignores the value underneath at 100% strength. It completely ignores the value of this layer underneath. And then here it blends it together. Setting it to multiply then removes the white and then allows the brightness underneath to show through. It's a little confusing, but that's how you can stack those. Now, if I set this to add mode at full strength, it's subtracting all of the black. And if I set it to subtract mode at full strength, it's subtracting all of the white. But then if I bring this strength down and this value down, now you can see there's more control over this. So normal is using this as a full opacity of white and black. Multiply is just multiplying the black only. Add is removing out the black, and subtract is removing out the white. So there's a lot of flexibility with the blending modes of these options in this one channel alone. Now you'll notice in here, there is no RGB slider. So if I change our color back to the default, you see we have a color mixer in the color slot. We have color mixers in luminosity, but in diffusion, there is no color slot. It's just a brightness value slider. Now, I was giving out some bad information because I thought that I could tint the diffusion channel with a color and then it would multiply that color on here, like much like you would in Photoshop. If I had a red set to a multiply, it would be a darker red. This is only a grayscale channel. So if I change this from red to green, you'll see it's still only doing a grayscale value of those colors. So that was bad information on my part, and I'm glad I cleared that up. However, it would be nice to be able to tint this color in here. So it was wishful thinking on my part, but bad information that I was putting out there. So I'm glad I cleared that up. Other settings you have in here are this effect specular, which is on by default. So if you look at the illumination model over here, let's change this to blend, get a wider specular. And remember that illumination model is now in the color slot of R16. Effect specular, if I turn this off, you'll see the specular is then composited on top of the diffuse. If I turn it on, the specular is affected underneath the diffuse. Now this is great because if you're making a dirt map or a grunge map or something, you want your dirt to go over your shiny surface. So it's smart that this is on by default, but it's great that you have the option to turn it off depending on the effect you're trying to achieve. In addition to affecting the specular, you can also affect the luminance. And the luminance is specific to this luminance channel. So when you turn luminance on, let's turn that back off for a second. Luminance turns the texture into a light source. So if you were making a texture for a light bulb, you would turn on the luminance channel and this becomes light, which isn't affected by the shadows in the scene. So the diffusion, again, if we're creating a light bulb, you could tell the diffusion affect that luminance channel. So then that gives you the effect of like perhaps you wanted to put some dirt over a light bulb or mask out the luminance source using any, again, it's not just the noise. We could put any procedural shader in here, or you can load up any texture that you want. And pure black masks it out and pure white shows through. And we'll turn off luminance. Same holds true for reflection. Turn off that and come to our reflection channel. And you can see that our diffusion is now masking out the reflection. And also it's affecting our specular. So if we wanted to turn that on, then the specular shows through. It's affecting our luminance. Turn our luminance on, and you can see that is affecting luminance or reflection and specular. So you have a lot of control over this channel here. Now I wouldn't necessarily rely on using the diffusion channel to mask reflections. I would probably go into the reflection channel itself and put a mask on the reflection, but this could be used in combination just to add, like I say, some dirt or something over the top of the reflection. So let's turn those off and set this back to the defaults. And that is the diffusion channel. Next down the line is the luminance channel, and there's no change between R16 and R15 in luminance. And in this channel, as we stated earlier, this is where you can turn a texture into a light source. And you apply this to an object in a globally illuminated scene. This will actually generate illumination and light into your scene. And this is controlled with the brightness slider. The lower you drop the slider, the less luminance that the object gets. But this is kind of fun because you can cheat subsurface scattering on like maybe smaller objects in the background that you're not going to see up close. You can give the illusion that it's absorbing light and diffusing light inside because the shadows will be less intense, and you don't take a hit at render time for this effect. This works like for small little plastic bits or something in the background. I use that all the time. But this is actually where we do apply subsurface scattering, and this is under the texture effects subsurface scattering. And inside here, there are some presets for subsurface scattering, which basically just picks light for different objects or different materials like ketchup, milk, apples, chicken, and that kind of stuff. And it just roughly calculates the color of light that would pass through an object. We'll get into subsurface scattering later on when we're building some textures in a future class. And into all the specific settings for distances that the light travels through the object, the differences between multiple and single, so forth. But this is where you would do subsurface scattering in the luminance channel, because subsurface scattering is about how light gets diffused under the surface of an object, and light is luminance. Also in here is the Loomis shader, and Loomis was used to get a better specular than the default specular channel was in legacy versions of cinema, because it gave you 3 separate speculars, so you can get a real hard ping and then some fall off going on here, as well as an anisotropic setting where you can actually recreate the look of scratched metal on things. Now, a lot of this has been translated over into the new reflectance channel in R16, so I'm not sure if I'll still be using Loomis as much as I used to, now that I can do everything in reflectance with the anisotropic settings and better control over specular in the new reflectance. But this is where I used to apply the Loomis shader, because the specular was, again, another source of illumination. And much like diffusion was a multiplier, where it subtracted white away, luminance is an additive where it subtracts black away. So if I change my color to black, there's no effect if I turn luminance on or off. And that was the same aspect with diffusion, that when it's on, it's basically filling that with white and you don't see the effect. Luminance, think of luminance like a screen or an add blend mode in Photoshop. So values of pure black will have no effect, and then anything brighter than black will start to affect that channel. So if I bring this brightness way down to 0, it has no effect at all, just like when I change the color to black. And as I start to creep it up, you can see it starts having an effect until I'm pure white and it becomes a pure light source. And as we were showing in the diffusion, you can put noise here in the luminance channel, and it almost looks exactly like when we were putting noise in the diffusion. Also, I use Fresnel in the luminance channel a lot to do my trick where I fake the rim light, where I can just pinch the gradient here, and Fresnel will only fall off on the rim of an object. Many uses for the luminosity channel. We'll get into some more of those. Again, your mix modes and your mix strength, just like I explained in the diffusion channel. Let's take a look at transparency now. R16, R15, and again, side by side, these are the same. So nothing new to learn here, but let's just run down the list real quick. Again, you can tint your color of your transparency any color. Notice when it's at pure white and 100%, you see nothing out here, but then when we start taking these numbers down from full value, the color starts showing through. And if you want to leave it white, then you can just change the brightness of this channel, and you can see the transparent object starts showing through in this way. Now, most transparent objects in the real world, like glass or water or ice, they have an index of refraction. And what does that mean? That means when the light hits the surface of a transparent object, it starts to bend. The light waves start to bend. So water has an index of refraction of 1.33, and you can see it starts to distort the light beams as they go through the object. Now, I'm going to point out one of the most handy tools in Cinema 4D, and if you don't use this before you go out to YouTube or Google to find something, you're doing yourself a disservice. The help menu in Cinema 4D is jam-packed with information on every single feature in here. This is absolutely phenomenal, and if you haven't gone through here to find things, you're really missing out, because they break down every single setting and tell you what it does. And here, as you can see, even in the refraction, it shows you what index of refraction is for different types of transparent objects, from the vacuum of no air to ice, water, glass, all the way through. So this gives you a list of most transparent types of objects and how the light will bend through those objects. For the most part, I'm assuming all of us are going to be using ice, water, and glass. So know that that's around 1.3 to 1.5, well, all the way up to 1.9 in this case here, but glass is around 1.55 and water is about 1.33. This is a really handy tool. In fact, in the transparency shader, I'm going to be popping into this to explain some more stuff because Maxon can explain it even clearer than I can as I'm mumbling to you guys through a microphone. We also have internal reflection and exit reflection. So if I just check these on and off to see what they do, look what's happening here. Now we just get the refraction, but we're not getting any of that reflection bouncing around inside. And notice when I turn total internal reflection off, the Fresnel reflectivity dialog grays itself out here. And if I have internal reflection turned on, we get one hit, like when the light goes through and reflects. Then we have exit reflections, and that means as the light's going back out, does it reflect again? So if we look at the help menu again for transparency, here's a great example of exit reflections. You can see here at the top, the exit reflections are enabled, so you see the reflection on the face and you also see it going around the backside, where when exit reflections is off, you're only getting the front reflection. Same with the Fresnel reflectivity here. They've got these nice little handy renders. This is what I love about the help menu is it's not just words. It has very descriptive pictures to tell you exactly what you're looking at. So look here at the Fresnel reflectivity. There's some extra detail that you're capturing here in the refraction of this object. When it's set to a low value, you're not getting those features in here. It could definitely speed up render times. You take the biggest hit at render time on transparent objects. So any knowledge you can have of these settings and what they do, and if you can turn something off and not lose the quality of your object just to speed up your render time, it's going to help you tremendously. So it's very helpful to understand what these settings are doing and if they can speed up your render without losing the quality on your image. I guess it depends on how complex your image is and how close or far away you are from it. But these are handy settings to know that you can mess around with these and speed up render times perhaps. The way I understand additive to work, this is kind of an override from reality. As the light bends around the edge of an object, reflection and transparency, it becomes opaque of what it is in the real world. Additive overrides that and just gives you the bright mode. So if I turn this transparency back up to 100%, you can see this additive mode is just really blowing out that transparent object. But you can play around with additive mode with colors if you want. The other way to do this is if you turn off additive and use the absorption color. Now, absorption color, you can set an actual distance through your object. So let's say we want our transparent object to be clear in the thin parts of the object, but then at thicker areas, we want it to start showing some color. You can add the color into this section and then define how far you travel into that object. Defines the density of the color. So 10 centimeters you can see is just really, really thick. So it's barely transparent. Where if I set this up to 500, you can see it's just getting a hint of this red color. So this is handy. Let's again go to the help menu. Let's look at this render they have supplied us. So the absorption color on this one is green, this one's blue, and then this one is normal or the white. And you can see the thinner areas aren't showing that absorption color, but as the object gets thicker, as the glass here gets thicker, it starts to show that color. So this is how we introduce color into our transparent materials. And then finally, we've got some blurriness, and this can give us the illusion of frosted material. So it's transparent, but it gives the illusion that it's not a completely clear material. Now, you can see just from the preview how long it took to draw this, so that's really going to take a hit at render time. So it's advisable you use this setting with caution. In fact, it's advisable you use transparency with caution altogether, because you will take the hardest render time hits with transparent objects. Use it sparingly and only if you need to, and then tweak those settings the best you can to speed up your renders, especially if you're doing animations. Still images are one thing. You only have to render one image. But when you're trying to do 24 frames a second for a 10-second shot and it has blurry transparency in it, hopefully you have access to a render farm. Okay, so that's transparency. We're going to skip over reflectance for right now, because this is the major overhaul of R16. This is where a majority of the changes of the material editor have taken place. So we'll skip over this and come back to it and wrap up the class talking about the reflectance channel and everything in here, because it's so multi-layered in here. Let's quickly look at the rest of the channels in here, and then we'll come back to reflectance at the end. So environment in R16 matches environment in R15. Let's turn off our transparency here. And you'll see you have the same RGB color sliders, the brightness slider, and a texture slot in here. So an environment map, what is that? The best way to describe it is it's cheated reflection. So if you have a heavy reflection scene with a bunch of objects that have all shiny reflective surfaces on it, that could take forever to calculate and render. The cheat is an environment map. In an environment map, you can load a texture or a photograph and then just have it wrap itself around it, but it won't look like a decal, like a texture applied in the color channel. It will take on the appearance of being a reflection map, but it's not true reflection. So the best way is, let me jump into R15 to show this, because I don't want to confuse people with the new reflectance channel when I'm just trying to explain environment. So in here, I have a quick scene I built. We have a floor, a sky object with an HDR on it, and a compositing tag that's telling it not to be seen by the camera. I have a sphere in the middle with a light. On the sky object, I have an HDR in the luminance channel, and this was just an image that was in the content browser that shipped with my version of Cinema 4D. When you put an HDR in the luminance channel, it doesn't receive shadows, so it's a full constant value of itself. It projects light into a globally illuminated scene if you have global illumination turned on, and it also provides an image to reflect back onto any shiny objects that have material in the reflectance channel. So I create a texture with reflection, just a full reflection in here for this example. So it's like a shiny mirror ball. And that texture is applied to this object here, my sphere. And the sky has the HDR. And when I hit render, you'll see this sphere, this mirror texture, is reflecting the floor back up onto it, and it's reflecting the image that's projected on that sky dome around it. So the difference here is if I move my camera around, you'll see I just am getting a preview of the gray shaded object in here. And the gray is just reflecting what's in the color map of this reflectance channel up here. So if I turn reflectance off, you see that's gray. Turn reflectance back on, it's just showing the gray in the preview. If I put the environment texture on that sphere, and again, if we look at that texture environment slot, I've loaded that same HDR that I'm projecting onto the sky object. So the same HDR is on the sky is now just being used as a texture in the environment channel. So I'm just going to delete the sky object. And you see that reflection is still showing up. So it does not need an environment to reflect on it. That environment map. In fact, I'm going to delete the chrome texture as well. So all that's happening now is we have a floor, a sphere, a light, and that sphere has the environment texture that has an HDR loaded into the texture slot. Now when I hit render, you see the HDR reflected in that ball. Now the difference is when I move the camera around here, I'm getting a real-time feedback of that environment map in this object using OpenGL right here in the preview editor. So that's interesting Although it's not an accurate reflection map, it's kind of a cheat, but it's nice to line things up. But the problem is, if I copy this sphere and paste it, move it next to itself, and hit render, not only is it not reflecting the floor into it, it's not reflecting the object next to it. So if I create a cube and I move that next to this object, that's not going to reflect in the object either. So it's a quick cheat. It's kind of like a video game reflection map versus like a real world reflection. And again, let's put the real reflection on the spheres. 1 and 2. And let's bring back our sky object and put the HDR on the sky object. And compositing tag, turn off scene by camera. Now when I hit render, you see this sphere is reflecting the cube next to it. These two spheres are reflecting each other, and they're both reflecting the floor. So obviously, true reflection is the way to go if you're looking for realism. If you're just looking for a quick cheat, or you have a bunch of shiny objects and you're trying to speed up your render time, try an environment object, but I certainly don't recommend it. Okay, back to our comparisons. Next down the line is fog. R16 and R15, again, no changes. They're the same across the board. Now, fog, this is interesting. This could be a little fun. If you turn off color and reflectance, let's check out fog here. Fog is a volume shader, and that means it needs to be in an enclosed object like a sphere or a cube or any primitive that has no open ends. It needs to live in a closed object. And I'm sure there's some uses for fog being viewed from the outside of an object, but it's meant to put your camera and your objects inside of the container and view it from within the denseness of the fog. And the distance here sets the scale of how far the fog interacts with your scene. So let me go to an R15 setup here. We've got a cube and two spheres and framing all the geometry. The cube is giant. It's 10,000 centimeters cubed. And I put small spheres inside. Let's just go back a viewport. And I applied the fog texture with a default distance of 1,000 centimeters. I've turned off all the other channels and the material is white. So when I hit render, you don't see the spheres because the thickness of that fog based on our scene and our scale is too close. It's too thick. So if I knock this back to say 5,000 centimeters and then hit render, now you can see the sphere that's closer versus the sphere that's farther away. And then if I dolly my camera way back, then they both start to vanish into the fog. And then the closer I get, the less fog it is. And you can see this one back here is still foggy. So it's nice to add some environment into your scene. The color, unfortunately, is fully luminescent. So your entire scene takes on the solid value of that color. There's no fall off on it. But I'm sure you can find some practical uses for it. But that's the gist of fog. Let's go back to our comparison. Now let's take a look at the bump channel. Let's turn off fog and turn our color and reflectance back on. And then in the reflectance, I want to set the Phong legacy to blend legacy so it looks like our R15 window. We all know Bump. Bump has no red, green, blue sliders. It is a value-only grayscale texture shader. And here we can load bitmaps, photographs, Photoshop images, and procedural textures. Just put some noise on here. We all know Bump takes dark areas and pushes them down, and light areas pushes them up based on the lighting in your scene. It does not physically displace the geometry, so you can see the edge of this sphere is still perfectly round. It's just used for inner detail to kind of fake extra detail in an object. We all know how Bump works, so I'm not going to spend any time on it other than If you change your global scale of your bump down to something like 20, you can see it's starting to create a double vision type pattern here. So if you're working with small scale bumps and you notice that the separation is looking weird, this is the delta. Just change the delta to match the percentage of the global scale, and that should help fix that. The other thing worth noting is this MIP fall off. MIP, if you look in the help menu here, MIP basically means as a bump texture vanishes off into the horizon, the scale of the texture is going to get smaller and tighter and get kind of chunky. So what MIP helps do is it diminishes the effect of that bump as it goes around and away from the camera. And this helps achieve a more naturalistic fall off of detail. So you wouldn't see super sharp detail on the edge of something in here. And by default, MIP is turned on for the bump channel. Now, much like the bump channel, we have the normal channel. Normal channel works instead of with black and white grayscale images, it works with red, green, and blue images to affect the normals on the surface of an object. So the best description again is going into the help menu here in Cinema 4D. You can see this is actually a great example. Here's a red, green, blue normal map. This map was generated off of this geometry, which has a lot of polygons to create this. So this is physically being displaced with geometry. And the more geometry, the longer it takes to calculate. This is one polygon. This shape over here on this side is one polygon that's been mapped with a normal map that was generated from this geometry. This creates this red, green, blue. When this is reprojected onto a single polygon, you get the illusion of just as much geometry with very little hit on processing time at render. So that's why a lot of sculpting programs, including Cinema 4D sculpting, they'll use low poly models that are subdivided, and then they'll use a baked normal map to create the fine details like wrinkles on skin or scales on a lizard or dinosaur. And you don't have to model all this detail, and it interacts with the lighting in the scene and gives a much better result than a standard bump map does. And again, you can combine a bump map on top of a normal map as well to get even finer detail in here. And then all of this can then be used with a displacement map on top of that. And a displacement map will actually physically displace the edge of an object, where a normal and a bump map are only affecting the inside, and they won't physically displace the outside, as you can see right here. This is the original mesh with a ton of polygons, and you can see how it displaces the edge, but over here you can see it's flat. It doesn't change the shape of the polygon, but a displacement map will do that. On to alpha. Alpha, again, in comparison to, sorry, I didn't show you, bump in both are the same, normals are the same, and alpha is also the same. And alpha just has a slot for a texture, and again, you can load a bitmap or any procedural texture, and it uses a grayscale value again. And in this example, let's just pinch our high and low clips here, and essentially you're just using a grayscale value map to create transparency in your texture. So if I bump the scale up on this noise, get a large scale, and really pinch these two together, now you can see I've got some holes in my texture here, and that's alpha. There's more settings we'll try to get into as we build our own textures in other classes. Glow, kind of useless. I would definitely recommend you add any type of glow in post instead of trying to burn it into your render, because you'd also be committed to this. If it's baked into your render, you can't undo it. You have much more flexibility in composition like After Effects or Nuke to add your own glow. So you can put an object buffer on something and use it to isolate. But you have settings for inner and outer strength. I'm not even going to demonstrate them because this is just kind of a pointless shader, in my opinion. I could be wrong. Maybe some people have used it to great extent. I just think it's kind of hokey. And again, here's the displacement that we were talking about. Now displacement, unlike bump 50% gray falls in the middle, black goes below, and white pushes up. Now in the displacement, you have the option to leave it intensity centered, which does the same thing. 50% gray stays flat in the middle, black goes down, white goes up, or you can also change it to just intensity. So black represents the current surface and white will push up higher. Again, let's just throw a noise in here to demonstrate. And that's intensity, and then this is intensity centered. You can see it goes up and down. Now this little preview won't show it, but sub-poly displacement comes in handy because you can add a displacement onto a low poly piece of geometry and then tell it at the time of render, subdivide it. Be very, very careful with this number. The higher the number, just think every single polygon on your object was going to be divided by this number. So if you have a single polygon, it's going to be divided 4 times, and that will add up very quickly. Rounded geometry just helps the edges, kind of like Phong shading does. It'll take any faceted edges and smooth them out for you. Again, you can load any procedural texture in here or a bitmap. And you have the ability in any channel to add a layer shader and start stacking these to get multiple, as we kind of briefly demonstrated in class 1, and we'll definitely be using that in future classes. I wish this preview was a little bit better. I guess you're just meant to look at it small, so it's kind of ugly. But this is a really handy tool, displacement, as you saw with the mountain in class 1. Turn off displacement. Editor. So let's look at editor between 16 and 15. Now you can see there are 2 things missing. Our specular and our specular color are no longer present in 16 because there is no longer a specular channel, which has now been moved up into reflectance. The editor tab, this is where you turn on animate preview. If you bring in an image sequence or an animation and apply it to an object, mostly I do this with flat plain backdrops. If I need to track a plate of a moving scene, of a filmed scene, I'll put it on some flat geometry. You need to come into the editor of that material and tell it to animate the preview in your editor. Otherwise, it'll just show the first frame. This next here is texture preview size is set to default. You can also set it to no scaling. This is kind of a precautionary setting. In case you bring in super large files, it won't bog down your system. It'll just kind of turn itself on to default and just do a low resolution preview in your editor window. So if you put a very large, look at this, you can go up to 16,000 pixel resolution image. If you were to set your texture, import a 16,000 pixel Photoshop file as a color channel, and you go in your editor and you tell the editor window to display that at its full resolution, and you put that texture on several objects, that's going to quickly bog down your editor and you're not even going to be able to move around in there. So it tries to make these really low res previews in there. But if there's a texture and you drop in on an object and you really want to see the quality of that texture, you can change this number from default to either no scaling, which will just keep the original resolution, or you can say, take that 16,000, don't show it small at 256, but at least show me 2,000 pixels of resolution of it. So you get a better idea in your preview window of what it's going to look like. And then this section just says, show all of these channels in the editor display window. I guess you could come in here and say, well, don't show transparency and don't show color. Why you do that, I'm not quite sure, but those are the options. And again, in R15 and earlier, there was also specular and color display, which is no longer here. We already covered the illumination tab in both versions. The model shading has been moved into the color channel. And then finally, there's assignment. And assignment just says, what is this material that we're working on assigned to in my scene? So if I create a material and I drop it on 10 objects, those 10 objects will show up in this list to tell me this material is on that. Also, I guess I should have mentioned the most important thing. This is where you name the texture you're creating, which is kind of important when you start creating several textures in a scene. It just helps you keep everything organized. And then this just allows you to add the texture to a layer in the project. So I guess that means we're going to talk about the reflectance channel finally. So let's pull those up, both 15 and 16. So I want to keep this an introduction to reflectance. I don't want to dig too deep into it because we could go on for another hour probably. There's so much to cover in this. So let's start with comparing the legacy reflection. You turn on reflection and you get a full mirror ball on here, and you can see the specular is being overlaid on top of that. You can add textures into the texture slot here. Most commonly used is Fresnel, and Fresnel can be set with these knots. You can invert them to have the fall off occur on the surface of the object. And in, I believe, R13, they introduced this physical Fresnel fall off with a bunch of presets for different materials, from water to plastic, copper, and so forth, to have more real-world accurate fall offs for these specific materials. Defaults to water. Or you can just turn that physical off. And then you have your brightness values here. Again, Fresnel is set to normal at 100%. It's completely overriding this. So we can scale Fresnel down and scale our reflection up. And we have control over these two blending modes of how much of that reflection we want to show. Bring these back up to 100. And then you have this setting to adjust the blurriness. So if I turn, actually let's turn the mix strength down so we have a full strength here, and blurriness, let's just set this to 20. And now you can see it's blurring the reflection here. Now to recreate these legacy looks in 16 reflectance, default the specular from the specular channel, as we've already discussed in length, is already created. So you would add a legacy reflection, and it comes in set to normal, and it's above the specular. So you're noticing we're not seeing the specular. So you can do one of two things. You can either change the normal mode to add mode, and now you can see that specular shows through. Or if you leave it at normal, you can drag it below the specular, and then the specular will live on top of it that way. Same thing here. Roughness is now the blurriness, so we can add that number in here. This color and Fresnel and mix mode, that all lives down here now. Texture, let's add our Fresnel. Let's bring this mix mode up to 50. Let's change the color of the reflection to red. And then over here, we'll change the color of the reflection to red. And we'll change the mix strength to 50. And now you can see our textures look identical if I come over here and set the blur to 20. You see how quickly we've recreated a legacy reflection, which means if you've created one in earlier versions and open it up, it should look the same without you having to do anything. So that's how the new reflectance compares to the old reflection channel. But let's go ahead and delete both legacy shaders in here. So now you can see we have no specular and no reflection at all. And there are several new models in here. If you just hit add, you can see you have Beckman, GGX, Fong, and Ward. These are all reflection models. Beckman should be used for smooth surfaces. GGX has been described to be used with metal surfaces. But then there's also the anisotropic, which gives you the metal scratches. And here's our legacy shaders here for reflection and the specular hits. This one's fantastic. Here's the new cloth reflectance shader. Takes a little while for the preview to open up. There's all these presets in here for the cloth. Sorry, wrong one. Come down here. Bunch of presets for different types of woven textures, and watch the preview as it updates. So go ahead and poke around in here, see what all the different settings are. You can adjust the colors and the scales, everything on here, the fall off. Really great looking stuff. Now recognized here we have Lambertian and Oren-Nayar. What does this mean? Why are these in here? Well, what we can do, let's turn off our color channel. It's possible to actually create a texture completely within the reflectance channel now, but it's not really recommended to do that because global illumination requires information in the color channel of a texture, and it won't pull that information from the diffuse. But if I wanted to create a red material, I could just add it to the color channel here and then adjust the reflection strength. And you can see quickly I'm just building a base color and I'm only using the reflectance channel. Now I can add a second reflection layer. Let's add another Beckman. This one I'm going to bump the roughness up to 50. Then in here, I'm going to twirl this down and look, each one of these has a texture slot. In that texture slot, I can add a surface of a checkerboard. And that checkerboard is going to act as a mask to this roughness. And it's allowing the roughness to show through in the white area of the checkerboard and not through the black area. So I could change the frequencies on this checkerboard, make it 10 by 10. And now you can see the roughness is only showing through the white areas of that checkerboard. I can also tint this reflection, kind of make it a green color. And then instead of adding the Fresnel in the mask here, there's these built-in Fresnel layers now for specifically for reflectance. And there's two models. There's a dielectric, which has all the physical Fresnels that we saw in our 15 shader. And there's also the conductor, which now has presets for all these different types of metals. Now this is really great. If you come into the help, look at the example renders for all the different types of metallic Fresnel fall-offs. These are just as is. You set gold, you'll get this color, and copper, you'll get this color. These are great. This is a really handy reference in here for R16 reflectance. If you have any questions about what any of the settings do, come in here and look at the examples, look at the renders. This is great. Here's a roughness chart that will show you what all the different roughness settings are going to do. And even better still, this chart here shows each model, the Beckman, GGX, Fong Ward, anisotropic, the Lambertian, the Oren-Nayar, and the cloth. At various stages of roughness, it shows you how the specular is being affected in these little windows here and what the overall look is like. And it helps you decide, if you're going for a specific look, what is the best shader model to use and what's the best roughness to use. It's a really great handy reference chart in here. Plus all the other explanations of the anisotropic settings, how to build multi-layered lacquer materials, like car paint. And this is looking pretty gross, so let's tone this down a little bit. And let's add another layer. Another Beckman. This one, under bump, if I twirl this open, I can change default to custom bump or custom normal. So let's do a bump map with some noise in it. And now you can see I've added noise to this without any noise in my bump channel out here. And this bump is not affecting any of the other reflection layers, just the one layer that I'm working on. So this is very powerful. Come in here, scale my noise down to 50%. And then in the texture slot above, right here, I can then add a mask. So if I put a checkerboard in here, now you can see I'm masking that bump in that channel right here. So here's the bump and here's the channel. And I can also scale the bump map strength back, or keep it strong if I want. And in this case, I want to invert my checkerboard so I can see in the highlight area the other texture we've got going. As soon as I set a Fresnel, oops, went too far, I went the wrong way. Actually, that's kind of cool though. That was an accident, but let's keep going. And let's add a Fresnel onto this layer and maybe bring up the index of refraction. And now you can see quickly I built a very ugly material. Let's tint the color of this one blue. And then add one more Beckman on top. And let's set the Fresnel on this as well. This gives a shiny gloss over the top of everything. So let's go back to this third one maybe and bump up the roughness on it. So this is one of the most hideous materials we could have done to explain it, but this was not about creating a pretty material. It was about showing you how there are channels for masking in each one of these. You can mask speculars and reflection and roughness. There's different shading models from cloth to Beckman to the diffuse layers of our color models and our legacy shaders and reflections. You can tint colors in here, set Fresnel masks, now with conductive material like metal material, Fresnel fall off if you so desire in here. So much more to cover in this channel, but this class is going on far too long. And I promised I'd show Cinema 4D Lite R16 material editor as a comparison to these as well. So first let's look at the Maxon full comparison of all the features. And if you look across the board here, you've got every version of Cinema 4D R16 and all the features from Light, Prime, Broadcast, Visualize, and Studio. And you go down the list and you can see Cinema 4D Lite is missing a few features. You get into the camera and Prime is missing some features. Further you go down, the more features start to disappear. Sculpting is only available in Studio. Material and texture, this is what's important here, because everything we're doing in the reflection channel, all the features are going to be available to everyone except for a handful. What are we missing here? Cinema 4D Lite and Prime and Broadcast cannot do sub-poly displacement, subsurface scattering, terrain model shading, brick and wood shading, sketch and tune. They don't have texture manager and the grass and material shader. So that's not too bad because some of these have brick and wood. Not all of them were omitted. I was just reading off the list of the few packages that don't have all of the settings in here. Lighting, we're going to be missing some. Global illumination is not going to be available to people with Cinema 4D Lite, and the physical renderer is not available in Prime, and that's something I use heavily, physical renderer and global illumination. So if you have Cinema 4D Lite or Prime, you're not going to be able to do those. So you can get Cinema 4D off the Effects PhD VPN if you want to try these features out in your version doesn't have these. I use the physical sky a lot. And we're going to be playing with subsurface scattering down the line as well. Again, check out the feature comparison page on Maxon if you have any questions about what your version will do. And with that, let's head into Cinema 4D Lite R16 and just take a quick look at the material editor in there now that we're familiar with what it looks like in R16 versus R15. But before we head over there, I just want to point out two things I forgot to mention. You can stack up to 16 layers here in the material editor. So there's plenty of room to experiment with scratches and bumps and fall-offs and everything, so you can have a lot of fun stacking things in here. The other thing I wanted to mention is here, if you turn on a transparency layer, and let's just add an index of refraction just so we can see it. If you enable transparency and then come back to reflectance, there's now a transparency layer in here, and you can control the shader Beckman GGX Phong of that reflectance, the reflection in the transparency as well. So that's a separate control in here. Just wanted to point that out. Okay. Now let's go back to looking at Cinema 4D Lite R16. Okay, here we are in Cinema 4D Lite R16 that ships free with Adobe After Effects CC Creative Cloud subscription. If this is the version you have, let's take a look at the material editor and let's compare it to what we've been looking at. And now that we're very familiar with all of the settings, as we just spent the last hour plus going through it, let's see what we've got. We've got color, we've got our color swatches, our brightness slider, our textures, our Lambertian versus Oren-Nayar. We have our diffusion channel, which is a grayscale channel. We have our luminance, which is red, green, blue, with the ability to add our procedural shaders. Our transparency layer, we turn on transparency, add index of refraction. Looks like everything's working. Absorption colors. Fantastic. Everything's working in here. Environment, fog, bump channel. Let's add a little bump. See what we have. Add a little noise. There we go. This is great. Normals, alphas. Let's add a little alpha noise. Bump this boy up to 500. And let's high clip and low clip that. Look at that. That's fantastic. Let's open this up. Not the prettiest texture. Look, it's even got glow, our favorite. We love glow. And look at this. You even have displacement. That's great. But as noted in that comparison list, there is no sub-poly displacement. So it won't be subdividing the polys to get more resolution in there. So you'll just have to create a high density mesh if you want to use this setting in here. But this is fantastic. It looks like everything's in here that we need. Editor, even, I don't know why it's allowing to generate GI if there's no global illumination in this. And there we go. C4D R16 Lite. Looks like you'll be able to follow along with any R16 material shaders that you see for the most part. Okay, everybody, this is ugly. I want to close this down as we wrap it up. Ooh, I even want to delete that. That's horrible. So I know we covered a lot, and we probably only touched the surface of the material editor. I just wanted to hit the highlights of everything. I wanted to show, most importantly, the differences between the new version and the old version, and show you that you can still recreate old textures in the new version, as well as the new version's not as scary and overwhelming as it may seem, and it's got some great new features that we're going to be able to tap into in the future. Next class, we're going to be creating a model to apply some texture on, and hopefully we'll pick up some modeling tips along the way, and we'll actually start creating a couple of custom textures of our own to put on that model that we create. Until then, have a great week, and if you have any questions, be sure to post them on the forum, and I'll try to answer them as quickly as I can to the best of my knowledge. See ya.